Friends, in the next few videos, we will solve some interesting problems using Monte Carlo simulations. Okay, so let's imagine we have a line segment of length 1 meter. Okay, so let's say uh, for simplicity, let's assume it's lying along the x-axis. So the starting coordinate is 0 and its length is 1 meter. Now we are picking two points randomly on this line segment and we make a cut at that points. So essentially we are dividing this line into three segments, right? For example, let's say we happen to pick up this point x1 and another point x2. So we cut this line into three segments and then the length of each of these three segments is, let's say, s1, s2 and s3. Now the question is, can we form a triangle with these three segments? So what is the probability that we can form a triangle with these three segments? For example, in this case, let's say we roughly cut the line into three equal proportions, right? So using these three segments, yes, we can form a triangle, right? But let's take this scenario where the two segments happen to be very small and the third segment is very long. Now, can we form a triangle with these three line segments? The answer is no, right? So we want to simulate this system so that we can answer what is the probability that these three segments make a triangle. Okay. Now, all right. So again, we are going to do n number of experiments, large number of experiments or simulations, and the total number of favorable outcomes or the number of triangles is 0 to begin with. Okay. So we loop over the experiments and then we are picking up two random numbers. So as you know, this will generate a random number between 0 to 1 with uniform distribution, right? So any number between 0 to 1 is equally probable. Okay, so we picked up two numbers, x1 and x2. Okay, and then what we want to do is, first we want to measure the length of these three segments, right? S1, S2, S3. So what we are doing is, let's say the point x2 happened to be larger than x1, something like this, right? X2 happened to be larger than x1. So what this means is 0 to x1 is going to be our first segment, x1 to x2 is going to be our second segment, and x2 to 1 is going to be our third segment. Now, if we want to measure the length 0 to x1, that would be x1. So the length of the first segment s1 would be equal to x1. Now the length of the second segment s2 would be x2 minus x1 because x2 is larger, right? So x2 minus x1, that would be the length of the second segment. And finally, the length of the third segment would be, here the endpoint is 1, so it's 1 minus x2, right? So this is the case when x2 is larger than x1. So here what we are doing is, if x2 is greater than x1, length of the first segment s1 is going to be x1, length of the second segment s2 is going to be x2 minus x1, x2 minus x1, and the length of the final segment s3 is going to be 1 minus x2, 1 minus x2, which is what we have here. Now, if it's the other way, for example, let's say x1 happened to be greater than x2, the logic simply reverses, right? So the length of the first segment x1 will be x2 because this is x2. Length of the second segment will be x1 minus x2, and finally the third segment will be 1 minus x1 because here we have x1. Okay, so far I guess up to this point is clear. All we are doing is, we have a line between 0 to 1 and we are picking two numbers randomly on this line. That means we have divided the line into three segments and we are measuring the length of each segment. So with the help of this random function, we know it generates random numbers between 0 to 1 uniformly. So for each trial, we have generated two random numbers, and based on those two random numbers, we have measured the length of the 3 segments. Okay, up to this point clear. Now we need to check if these 3 lengths or the segments can form a triangle. Now for 3 lines to form a triangle, the condition is the sum of every 2 segments should be greater than the sum of the third segment. Okay, for example, S1 plus S3 should be larger than S2. Okay, similarly, S1 plus S2 should be larger than S3, and finally S2 plus S3 should be larger than S1. So which means the sum of any 2 segments must be larger than the remaining third segment. That's the criteria for 3 lines to form a triangle. Okay, so here what we are doing is we are checking if S1 plus S2 is it greater than S3, and S1 plus S3 is it greater than S2, and finally S2 plus S3 is it greater than S1. So we are checking for every 2 sum of the 2 segments is that larger than the third segment. Okay, if that's the case, that means we can form a triangle with those 3 segments. So we increase the number of triangles or the favorable outcomes by 1. Okay, and after this, now we are just making some print statements. So the total number of trials or the number of experiments we have done, it's about 1 million experiments we have carried out. And then the number of favorable outcomes, it's roughly about 250,000-ish. So the probability of forming a triangle is 0.25, roughly 0.25 or 1/4. Okay, so you see how we can solve some interesting problems in maths also using Monte Carlo simulations. Okay, in the next few videos we will solve some simple problems like these so that we can build the intuition, we get more practice. That's all for today.